Here we have another absolute value problem, but this time it's an absolute value inequality. This says that our distance from 0, notice how the absolute value is all by itself on the left-hand side. Okay, there's our inequality. So on the left, the absolute value is by itself. So here's what it means. The distance from 0 is less than 4 units away. That means I'm this way, less than 4, or I could be greater than negative 4, because those would be less than 4 units away from 0 as well. So I'm going to write those two statements. I'm going to say, hey, the x minus 10 could be less than the 4. That takes care of this stuff. Or I guess this is an and statement, less than. X minus 10 is greater. So we're going this way now, the negative 4. So the rule that we talked about in class is you write it once the way you see it without absolute values. X minus 10 less than 4, x minus 10 less than 4, less than or equal to. Then you write it again, x minus 10, but you flip the inequality and you change. Flip and change for absolute values. But once you've done that, now it's just solve. Plus 10, x is less than or equal to 14, add 10, x is greater than or equal to 6. Again, we take a quick look at it. Greater than 6, or equal to it, less than 14, or equal to it. We're looking for the overlap. We want everything between 6 and 14. And so that's what we write for an answer. Inequality notation looks like this. X is trapped between the 6 and the 14. Interval notation looks like this. It goes from low number to high number, 6 to 14. It includes the 6 and it includes the 4. So the top one is inequality notation. Bottom one is interval. They both tell the same thing, just different ways to express our answer.